And restart.
Okay, so welcome everyone. We are recording this, so if you don't want to be recorded, turn off your camera. And the agenda is kind of short today, but we have an interesting topic to discuss regarding Bloom filters and possibly pivoting to structured metadata. So, who wants to get started with that? We have like a bunch of questions that I think Ye and Nicole pulled together. So maybe between Christian and I, we can answer those.
Yeah, definitely.
Nicole, do you want to answer all the questions with the white dots and I'll ask all the questions with the black dots?
Sure. But maybe Kirsten, you can tell us first what the Bloom filter changes are.
Yeah. So since Loki release 3.0, we have been working excessively on the Bloom filter feature, which is already one of the major features of 3.0 in general. And we've been iterating a lot, trying out different ideas. That's also why the feature is marked as experimental in the beginning at all, because we need to kind of make this work for large scale, so we can also use it internally at Grafana Labs. And that's why there have been quite a lot of changes. And I want to mention the major changes that we did in the past couple of months. So the biggest change actually that happened recently is that happened on the right path for Blooms. In the very beginning with Loki 3.0, we had a component called the Bloom compactor, which was responsible for building the Bloom blocks from the chunk data from the log lines and uploading the blocks to object storage so they can be data queried. And this Bloom compactor component worked in a very similar way to the regular compactor. It's a stateful set when you run it in Kubernetes. Basically, the component was using a ring to determine which instance of the Bloom compactor does what part or what chunk of the work for a specific tenant and a specific time range, basically. This made the operational burden quite high. Stateful sets in Kubernetes are very hard to operate. Anytime you have a topology change in the ring, it means that ownership gets reassigned. You're doing rework. It's not very efficient. You have hardly any control of splitting the work more granular between compactors, or you can kind of distribute. Since some compactors do more work than others, you can't, if you're just plain stateful set, you can't kind of distinguish what the individual instances are doing, and some of them are idling, some of them are doing way more work. So this Bloom compactor therefore has been replaced by two new components. Seems more complex at first, but the two more components are, one is a planner component, which is still a stateful set, but it runs as a singleton. And this component is really just responsible for planning the work out for building the Blooms. And the second component, the Bloom builder, is a stateless service which pulls the work from the task queue from the planner. And basically you can scale the amount of Bloom builders very easily horizontally depending on your demands. So you can scale up and down, and there's no reassignment of tasks, but every stateless builder kind of pulls the task that it should work on. So it's much more evenly distributed, and by running these builders also statelessly on, you can run them on spot instances. For example, if you use a managed Kubernetes service, and spot instances are way more cheaper, up to 75% cheaper than the regular ones. So with the same amount of workers, you can achieve like way lower TCO. So that has been the big change in the past. What we see so far already is removing all the code from the Bloom compactor from the GitHub repository and replaced in the deployment for the Helm deployment, replaced the compactor also with the Bloom planner and builder components. And with going forward, we only use the planner builder setup for new feature development.
Okay, so would you say that the planner and builder together are doing the same work of the compactor, or and it's just that it's more scalable, or is it a totally different thing?
They're doing exactly the same work. Like the implementation of the work that is done is basically identical to what the compactor did in a single component, but it's now splitting up into the planning and the building phase. That's why it's much more easy to scale and to operate. But the work is essentially the same and to produce the same output.
Can I sort of ask a question? So does the Bloom gateway still exist? Is that still a way of interacting with the Blooms, and it's just this component gone? And is there any other interactions with other components within Loki that's changed compared to the old architecture? Or do you know the queryers or the indexers still talk to Blooms, etc., to get their information?
The read path stays the same. Since the output of the Bloom planner and builders is identical to what the compactor did. The Bloom gateway can use the same blocks, the same format. Everything's the same. So the read path didn't change at all with regards to the change. The Bloom gateways are still responsible for filtering out the chunks that don't contain the searched the filter criteria, so to reduce the amount of chunks that need to be searched for the specified search term. Yes. So there's no change in the read path at all with regards to that.
Okay, so I mean, on one hand, there's this surface level change of the Bloom compactor not being there anymore and instead being replaced by the planner and the builder. But also, how does that tie in? It seems like there's also been a change in direction towards structured metadata.
Mm-hmm. So that is the upcoming change that we are started working right now, more or less. And this is a bit of a pivot in not in the way how we index data, but the way what we index. And the shift there is that we essentially decided to move away from indexing engrams of the logline content towards indexing the plain structured metadata values. And the reason for that is that what we've seen so far is when you index engrams of the log lines, this is a very universal concept to index a large blobs of text, which log lines can be. But you index basically every single detail for every single log line. And log lines contain a lot of course, a lot of redundant information, a lot of information that probably is never queried. For example, be it timestamps or specific names, keywords that you probably never want to filter out in needle in the haystack queries. So there's a lot of data that has been indexed when which is never being queried, and this results in very large Bloom data files, Bloom block sizes, which had turned out to be a very, very problematic in operational terms. So it's very hard to operate them at scale. When we started out with this, with indexing log lines, it kind of, the sizes felt manageable with low to medium-sized environments, like in our development environment. Everything seems still fine. But once we made the leap to more production environments, we saw that the amount of data that is indexed and never queried is kind of too big to make it easy to operate. And so what we also saw is from a querying point of view, that people know what they're querying for rather than just arbitrary data. And this is usually some identifiers, for example, trace IDs or other unique IDs, transaction IDs from their structured logs. And very often, people also already use that, use these IDs and index them into structured metadata along the log line anyway. So we are going to pivot in a direction where we, instead of indexing the log line, we index the structured metadata into the blooms, which significantly reduces the amount of data that is indexed in the first time. It is much more, much nearer to what people are querying for and what they're looking for. People are not looking for sub-strings, for example, of a trace ID, but they always know the trace ID up front that they are looking for, the full one. And we don't need to tokenize and create multiple engrams from a single structured metadata value, but we can just index the full key and retrieve that from the Bloomfield as well when you query it. So we save a lot of resources because we index way less, and at query time we have the advantage that we also don't need to we can basically look up the keys that are searched for more easily in the Bloom, which will overall bring down the size of the Bloom blocks of the generated data to make it manageable and operable at a large scale as well. So yeah.
So we kind of built structured metadata, what you're saying, for like to sort of solve the open telemetry problem of all of that metadata that comes with the payload. So do you see the role of structured metadata changing to be a much more active sort of an active tool that we use or that we tell our customers to use? And sort of with that, should they be like, shoving everything into structured metadata, or is there best practices around what they should be doing, and keeping in structured metadata?
So first, yes, indexing or this pivoting to indexing structured metadata fits very well into the concept of OTel, where attributes from OTel requests are kind of automatically transferred into structured metadata. And if you send the attributes in a thought through way, you can benefit first of all a lot from these fields being in structured metadata without, for example, needing to pass a log line that is JSON, even without the Bloom filter attachment. But now, by adding the Bloom filters on top of the structured metadata, it's kind of structured metadata become even more important than it is now with OTel. And I think it makes the OTel the transition to OTel even more compelling in a way when you say we're going to use that with Bloom filters to accelerate your query. With regards to the second question, then when people are using this as an open source or with our customers. Should they shovel everything into structured metadata? No, it doesn't mean that this is useful. It's only useful if you really want to, if you want to, or if you have fields that you are actively looking for at query time. So if you have a use case where you need to search like for trace IDs or transaction IDs, or some IoT use case for some device IDs, where you want to get all the logs from the full log volume, then it makes sense to use that as structured metadata. So except for the initial search term that you're looking for, additional attributes in or additional fields in structured metadata don't benefit from that. Like, it even makes it more complicated, because at the end you're still getting a log line back that you want to possibly filter on even further down, like that where you want to do also a string match later on, or transform the log line into something different, a different result. And of course, if you move, if you want to do that, if you still want to do that, you don't benefit from that being in structured metadata. You have to do that on the log line itself anyway. Yeah, so it really just makes sense for the specific fields that you're looking for, that want to filter down your needle in a haystack searches.
So does that mean that there are no current plans to improve the performance of querying, like the real needle in a haystack ones, queries where they're running solely on the log lines? It sounds like the shift is that we're doing that only for structured metadata now. So are we completely dropping that line of work, or is it more like we'll do that later?
Yes. So by indexing only structured metadata, we remove the capability of doing kind of accelerated search on strings on the log line itself. So it's really it narrows down. I would say it narrows down the use case of needle in a haystack searches, where up till now they were very general, where it's kind of almost like a not full text search, but into the direction of a full text search, where you have a large blob of text and you want to like search for occurrences of a specific term. But that shifted towards really a dedicated single field lookup, more or less, where you have one specific term that you know upfront, and might or might not be part of the log line itself. Can be some additional attribute, or it can be something that has been extracted at the client side already. Yeah, but because once you filter down by a structured metadata field, and you can reduce the amount of chunks that you need to brute force look at afterwards, you can speed. This is almost linear, right? The brute force search, you can scale almost linearly to a certain degree, and if you can kind of remove 80% of all the log lines that you need to brute force search, Loki is that's what Loki is best at its core, doing brute force search on moderate amount of unstructured log lines. So this is kind of a combination. It's like almost like a two-step. The first thing is filtering down the amount of work that needs to be done, or reduce the amount of work that needs to be done by looking at the specific field, and then apply the brute force search as a second step which is Loki is really good at.
Just to kind of like add a question onto that one with unstructured metadata, the way that it will now work, will you select which keys you want from the unstructured metadata to be added to the blooms, or would you just basically say we expect all of the keys in the unstructured metadata fields to be important, so we're just going to take all of them into that index?
Mm-hmm. As the first iteration, we are going to index all the fields of the structured metadata. We would like to keep it kind of minimal, the amount of configuration that you need. So ideally, it would be a single configuration, a zero configuration feature. But yes, there might be cases where you want to run Loki and you have a lot of structured metadata, and you know that you're only going to use 1, 2, 3, maybe a handful of fields really for searching. And this is very likely to be a second step that we say we have a include list of fields that you actually want to index. It helps to reduce the amount of work at creation time, right? So if you know upfront you only need a certain amount of fields, and you should be able to do that. It's not yet properly planned out how this is going to work, because the first iteration will be all metadata.
Okay, and maybe this is also like I'm not so clued up on how blooms work, so maybe this is a very beginner question. But what is the difference between like a highly indexed, a traditional database that has a very large index, and then having Bloom filters that run on structured metadata? Is there a performance difference between those?
So the main difference is that blooms can be very space efficient. It can be a very space efficient index for large quantities of data, because it's probabilistic data structure. It means when you look up a key in the bloom, and you get a kind of a match, when the bloom filter returns that it's contained, then it's probably contained. It doesn't mean that it actually is contained, whereas it's like the opposite around from other indexes, where for example an index of every field, and you know it's going to be there, and if you look it up and it's not there, it's not there. But it's kind of the other way around. It just means that if you get a probably true response, and by that this can be done by kind of overlapping keys internally in the Bloom filter, and that's the reason why it can be rather small compared to similarly working other indexes. Let's say it's probabilistic. You have a certain false positive rate, which is rather small. And it also doesn't really matter if you need to, for example, additionally search. Then if you don't filter out one, or if you filter out, let's say if you have 1,000 chunks overall, and your Bloom filter returns says you can filter out 900 chunks. It doesn't really matter if the actual thing you're looking for is only in 95 chunks, because 5 chunks had a false positive out of these 1,000. So I would say the main difference between other indexes is that it's just probabilistic and therefore it's still small, but the gain you get from even a small index is really high. And what we have seen is when this plays into the role was what you have seen. Large indexes, like if you index too much data into a Bloom filter, then it also grows to a degree where it's really hard to manage. And that's with traditional indexes as well. If they become bigger and bigger, I mean, of course they can make everything faster, but it's way more expensive to operate and it's way harder to operate. And that's what we try to minimize with Bloom filters.
So this kind of like brings a bit like, because I had like a novice question like Nicole there as well. So this is the whole reason for using like Bloom filters rather than index, like cardinality, and the fact that we're almost like we're taking chunks and we're guessing within a much like we're almost probably can't even say that word probabilistically or looking for say a trace ID rather than saying okay we're gonna every specific trace ID, which could just blow out your cardinality.
Exactly, yeah.
And so
really,
and
it's the space efficiency that make them really attractive.
And there's kind of no do blooms have like a shelf life? Will they eventually rotate out for for more, or do we can, because they're so small, we can keep them sort of indefinitely?
There is already a retention feature for blooms. So the bloom blocks, like the data of the actual files, are stored in object storage, and you can configure the retention for these files. The thing is, the nice thing about this additional Bloom filter is that you don't rely on the Bloom filter. So if the Bloom filter for a specific time or a specific data set is not there, it just means that we can't additionally filter anything, but it's not like that we are breaking or relying on that file being present. So it's very easy to just remove them. And it's just if you remove them at the same time where you remove the rest of your data, let's say you have a 30 or 60 or 90-day retention of your index and of your chunks, afterwards, of course, you can delete them as well. Or if you're saying you're querying only the last week anyway, or the last 2 weeks, then theoretically you could even delete the Bloom filters after this time, after 2 weeks, even though you still have the index for another month additionally, but you don't benefit from the accelerated search then after beyond that time of the retention of the Bloom blocks. The feature is already there, so you can configure that very similar to how we configure the retention for the chunks and index on the regular compactor.
So is the idea that if blooms are turned on, then there's going to be a bloom that's created for every log line that's ingested or stream that's ingested?
Yes, for every tenant and every stream, you have kind of a separate Bloom filter but multiple, to kind of keep the blooms organized. You can have multiple streams in a single file. Just live together. Multiple blooms of multiple series can be lived together in a single block, just for managing. That's like you have a certain amount of streams. They have an identifier, which is the fingerprint, and these identifier is kind of a range of it's the 64-bit range. It's a very high range that, like, you can distribute your streams really nicely across this range, and then you can split them up into parts, so every part has an equally amount of your streams. and you can then block them together into a single file. That said, this is how it's currently done. So you have multiple blooms of multiple streams in a single file. This is something which might change as well, or even likely to change as well, for the reason that at query time, if you need to download blocks to query the Bloom data for, if you let's say you have 100 streams with 100 blooms in a Bloom block grouped together, but you're only interested in looking at a single stream, or to filter out a single stream, you still need to download all 100 Bloom filters, which is not efficient on the read path. So by splitting up the Bloom blocks, or making blocks for a single series, we've been discussing that to do that, it allows us to more efficiently download the blocks for querying. And this will also make them smaller overall, because you don't group 100 streams anymore into a single block, and the block becomes, I don't know, 8, 12, 32 megabytes big. If you have 10 or 100 streams in them, the individual file size gets much lower, and it helps also to, for example, to cache these files in memory, and which makes them even more easy to operate and operationalize. So you can even run, or to query the blooms at some point is like in a stateless manner, where similar to chunks, you just fetch them from a memcache or intermediate cache, rather than from object storage. If they are below 2 megabytes, for example, the individual files, then you can kind of statelessly query them and distribute all the query work to the queryers, rather than a specific type, like a specific service, which is now the Bloom Gateway. The Bloom Gateway is a stateful service which also intermediately caches the Bloom blocks because of their size, which is problematic. And if we can get the Bloom block size down to very, like, below 2 megabytes, for example, for a single series, then it makes operations even simpler.
So what happens if there's a recording rule that is set up? Are blooms automatically built off of those?
Recording rules do not use blooms if you're running the recording rule in the ruler. So there are two ways how you can evaluate recording rules in Loki. One is on the ruler itself, which kind of uses the query engine from Loki, but it's single threaded and it doesn't do any splitting and sharding that is usually happening in the query front end. And the second, so then you can't benefit from blooms, but where you would automatically benefit from blooms is when you use the remote rule evaluation, which is the ruler just dispatches the query to the query front end to evaluate the rule, and then the regular read path is taking is used, which, depending on the tenant and the configuration, either uses the blooms or not using the blooms, but it would use the regular read path, and so it could benefit from the blooms. But I would say since rules are usually only evaluated in the very recent data, like the last 1 minute, 5 minutes, maybe 10 minutes, hardly anything beyond 30 minutes, I would say. They would not really benefit from blooms anyway, because it takes some time from ingest until the blooms are built. We've seen kind of like a delay of 6 hours, even more in our production environments, where we just, in order to process the amount of data and index the amount of data after ingestion, it's just you have this delay until the bloom blocks are ready and be used. That said, this will be reduced if we index less with structured metadata. So this will speed up by the amount of how much structured metadata is smaller than the logline data. But still, you're very likely not really benefiting from maybe the last hour or 2 hours, maybe, where you don't have blooms yet. And so it's not really, I would say it's not really a feature for rule evaluation.
So sort of like bubbling back up a bit then, if we have a look at what should our users sort of future proof or prepare for just to get ready? Because obviously there's a lot of work that you guys still need to do to get this ready for unstructured metadata. You know, what should they be looking at? Should they be looking at configuring, you know, their agents such as Alloy to start use structured metadata and start working out what they want to put in structured metadata? What's kind of like your advice to get them ready?
So the advice to get ready, I would say, is yes, start using structured metadata. If you have a very specific use case on how you want to query your logs. So certain, as I said before, certain companies are have their log use case built around very specific searches, trace IDs, where they want to trace a transaction or something throughout their whole system and see how this, like, to follow it, similar to what you could achieve with tracing, but maybe a bit more detailed, and with all the extra information that you have from logs. But yeah, like, if you have that use case and you know you filter on specific fields a lot, then I would advise to put it into structured metadata also instead of the labels. I mean, regular labels have this have the problem of you can't use very high cardinality fields or values on the regular labels, because that would affect how we store, or how Loki stores your logs, and that's kind of a restriction. The log, but the label values should be not too big, not too many, but also not too little. So you have a kind of a balanced distribution of how to store logs. But if you have very high cardinality fields that you query on, put them into structured metadata using Alloy, or even better, start using OTel, as discussed earlier, where this should be even easier if you have trace IDs as attributes, or put anything into attributes with OTel. I think this is the future-proof solution, I would say. Loki is definitely also using in more into this direction, just as a unified way to ingest any observability signals, really.
And I guess sort of like my final question. So if anyone had like started experimenting with like the compactor and, you know, bloom filters, is there anything you advise them to do before, you know, say they upgrade to the next version of the Helm? Like, should they be prepared, obviously, that component's no longer going to be there? So should they basically just maybe disable any of the Bloom features for now in the next iteration of the Helm, just to save any problems?
So for changing from Bloom compactors to Bloom builders, there is not really much to consider. If you're using Helm, for example, you should be the Helm configuration, the Helm default values should be sufficient. There had been some configuration changes, however, like some of the per tenant settings in Loki, if you've changed them, that have been prefixed with Bloom compactor, Bloom compactor something, because the topic was removed, they also got renamed to Bloom build instead of Bloom compactor. This is stated also in the upgrade guides, upgrade notes of Loki, so you can look at that. A few have been renamed that still exist now, but just moved to the Bloom build section of the configuration, and like settings that have been Bloom compactor specific are not there anymore. They've been removed and therefore also need to removed from your configuration. Otherwise, Loki won't start. So that's for the Helm and the regular Loki. With regards to the upcoming change with the structured metadata, this is going to be a bit more difficult though. Not in terms of what you need to deploy. The components are still the same. The problem, however, is that the Bloom blocks won't be compatible anymore. So you can't run both indexed loglines and indexed structured metadata at the same time. This is not backwards compatible. We're going to break this. We think it's easier to make a clear cut and say, if you want to continue with your indexing your log lines and you're kind of happy with that, you probably need to continue with your current version, and you can't upgrade, unfortunately. If you upgrade, you would need to stop building the blooms first, and to make the clean cut, you need to delete the blooms directory on object storage to kind of wipe the existing blocks. Not because they won't be used anyway. You theoretically probably could not delete them, but if they could be downloaded, and we would detect that they are not compatible anymore, and we would discard it again. So it's unneeded work that needs to be done. If you just remove after stopping the Bloom building, removing the blooms directory on object storage on the bucket that your Loki is pointing to, then you upgrade the components, the new component, or like the new version, which will be Loki 3.2. Then the new version will build only blooms from structured metadata, and also the read path will only accept those new blocks. You can specify anyway how much back in the you want to build the blooms for. So there's the min table offset and max table offset in the Bloom planner options to specify kind of how many days backwards do we want to rebuild the blooms for. And if you say you need the blooms, but now for structured metadata, you can say 30 days even to rebuild your bloom. It will take some time, but eventually we'll catch up and we'll rebuild all the blooms anyway. So yeah, this manual step of deleting the not compatible files from object storage. I think that's a feasible thing to do, because it definitely enables us to deliver this feature faster for everyone, and there's no real need for being backwards compatible, because you can't query blooms and log lines at the same time anyway with the same feature. So yeah, I think it's a good compromise with this regards.
Okay, that was it for me. How about you, Jay?
Yeah, you've absolutely crushed it, and thank you for letting us just dig into blooms in general as well. I thought we were just like, we have the masters of blooms on the call, so let's just go for it.
Yeah, it was great.
Definitely. I hope this is helpful for other people as well, who, when we have seen that the community is actively using blooms already with open source, they're posting issues, and we see them. It's not always easy to answer and support them as much as we would like to, but yeah, I think people will benefit from this as much as we do as a company. Having a feature that is just easier to operate and it has less data to deal with is just and has basically the same benefits is definitely a good direction, and we are excited about that.
Cool, folks. Yeah, thank you very much, Christian, for answering all those questions. That was a masterclass on blooms with Loki. So yeah, it's just us. I don't think anyone else is on the call, right? So I think we can call it a day. And thanks everyone for joining. And Nicole, will you take care of uploading this to YouTube?
Yes, I will stop recording right now. Thanks,
Okay.
everyone.
Thank you very much.